We move on to our next speaker, one of our own, Ms. Luna Baalbaki. Luna is a research data scientist at Stanford University's Department of Medicine, where she develops data-driven solutions to support ethical, trustworthy, and impactful healthcare research. Her work focuses on building robust data pipelines, applying statistical modeling, and leveraging machine learning models. With experience across academia, fintech, and nonprofit organizations, Luna has led projects spanning natural language processing, experimentation, and data-driven decision-making. She holds 2 master's degrees, one in business analytics from OSB, very proud of you, Luna, and another in economic development from the London School of Economics. Luna is passionate about empowering other women to pursue opportunities in data science and research. Welcome, Luna. It's great to have you.
Good afternoon, everyone, and thank you all for being here. It's always good to be back at my alma mater, AUB and OSB. Also, thank you, Dr. Lama Moussaoui, for the introduction. Before I begin, I want to share with you a quick personal story. And that is, around 8 years ago, I remember one day my dad came up to me and told me that, Luna, there is this Women in Data Science conference happening at AUB this year on Friday, and he asked me if I want to go. And back then, I didn't know what data science even was, but I was like, a day off from school, approved by my dad, that sounds like a great idea. So we went together, and on that very day, I really got inspired by the women there, and I got to know more about what data science is and the impact that it can do. And from that very day, my journey in data science started. So I want to thank the Women in Data Science organization team at AUB for hosting the events all of these years, because really one of these conferences inspired me to be where I am right now. So thank you a lot. And also, I want to thank my dad, who's right there, for taking me to the conference. That was us in 2017. I was 17 years old. And for today's agenda, I'll be going over what bias is, how to overcome it, and how to detect it. Also, I'll be sharing with you a recent research study that I worked on that shows how we can use AI to build health data models. And at the end, I'll go over some strategies to building trustworthy AI. So first, let's play a game. I want all of you to picture a farmer. So close your eyes and picture a farmer. Okay, now open your eyes. How many of you pictured a male farmer? Raise your hands. Okay, wow. Now, how many of you pictured a female farmer? Okay, only 2. Here's the thing. Out of all of the farmers in the world, 40% are female farmers. Yet, our brains, for most of us, defaulted to picturing a male farmer. And that's what we call bias. Bias is when our brains or our data lean toward one pattern and leave the rest out. So imagine we're teaching a machine learning model to recognize a farmer. But mostly, and with no intention, we're only feeding it and showing it images of a male farmer. So now the model is going to learn that a farmer is someone who looks like a male farmer, and everyone who doesn't fit this criteria is going to be left out. So later on, when we show the model a female farmer or an elderly farmer, the model isn't going to recognize them because they don't fit the criteria. And that's how our human bias affect our machine learning bias. And that's how our machine learning models become biased if we don't take the correct measures. Now, there are a couple of disadvantages that can happen when our models are biased. And one of them is we'll get inaccurate predictions, which would lead to wrong decision making. And the other one is we would have reinforcement of stereotypes. And also, we will get unfair treatments of certain groups, especially minority groups. And also, we're going to be losing trust in AI, and we will have legal and ethical complications. Now, for the research case study that I worked on, it was a very interesting project, and the objective was to build a machine learning model that would identify patients who have high risk of being readmitted to the hospital post-heart surgery. So basically, some patients would come to the hospital, do the heart surgery, and then leave, but a few days later, they will come back to the hospital with more complications or some complications. So our goal was to design this model to predict the high-risk patients so that doctors can intervene faster and do earlier checkups with them. And for our data set, we used data from different hospitals. We collected 10,000 records of patients. And for features, we got demographics such as age, gender, and race. And also we got clinical outcomes and surgical outcomes. And our target variable was readmission to hospital within 30 days post-surgery. And to build this model, first we got our data. We did some data cleaning and data pre-processing, and also we did some feature engineering. After that, we built our model. And after we built our model, we needed to evaluate it to see how well it's performing. And in order to do so, we pulled out some matrices. So we pulled out accuracy, we pulled out precision, recall, and area under curve. And as you can see here, most of the scores are in the 80%. And this means that the model, on average, it's performing well, especially for recall, which measures how well the model detects positive cases. It is around 80%. And this, at a glance, tells us that the model is performing well. However, here's the point. These scores are on average. So the model could be performing well for some groups, but performing poorly for others. And on average, the scores are good. But we shouldn't stop here. We should look deeper and check for bias. So in order to check for bias, what we can do is we can check for data distribution. For example, here, we got all of our patients and we tried to see the different percentage in ethnicity of patients. And as you can see here, for white patients, we got 60%. So 60% of the total data set that we collected has ethnicity white patients. And just 20% for black patients, 12 for Asian, 6 for Hispanic, and 2 for others. So this clearly tells us that our data is biased and it is not fair. And also, there's another way that we can dig deep into it. And as you can see here, recall, which predicts how model is performing for patients. And for white patients, the model is performing really well, which is around 89%. And for black patients, it's only 0.62%. And this means that we're missing around 40% of true high-risk black patients, which can have serious real-life consequences. And this shows us that our model isn't fair for the different subgroups. Now, another way to detect for bias is to use the ROC curve, which is the receiver-operator characteristic curve, which is used to show how the model is performing for different subgroups that we have. And as you can see here, the higher the line, the better the performance. And we can see that there's differences between the lines for different groups. So for white patients, it has the highest line, which means the model is performing best for white patients. However, for other groups, the model isn't performing as well. And this clearly tells us that we have bias and we should overcome it. Now, there are a couple of methods that we can use in order to overcome bias in our machine learning models. And one of them is to collect more data, to get more data, especially for the minority group, so that we can have more balanced data. However, in our case, in our research study, we couldn't do so because we were restricted on time, so we couldn't collect more data from different hospitals. So what we did is a technique called oversampling. And oversampling, it basically creates synthetic samples for minority groups, and that way we would have a more balanced data. And the way that the oversampling works is that for oversampling, we use the SMOTE technique, which is synthetic minority oversampling technique, to synthetically expand the minority class. And the way it works is that first, identify the minority class. So here, for example, the red dots, let's say, these are the minority class, and the blue dots are the majority class. So the first thing that it does is that it identifies the minority class. And then it finds the k nearest neighbors, usually 5 points around it. And then it tries to connect the point. Then it generates new synthetic points along the line. And that way, we would have more data and more weight for the minority class. And then we would have a more balanced and fair data in our models. And also to visualize it, oversampling, as you can see before, these are the points for the minority graph. Later, after we did the oversampling and we synthetically created more points, we can see we have more points along the same pattern. And we got results after the oversampling. So we also collected accuracy, precision, recall before the oversampling and after the oversampling. And as we saw before the oversampling, we got we got biased and unfair data. Whereas after oversampling, as you can see, for Black patients, it was before oversampling 0.62, but now it's much better, it's 0.81. So it's detecting 20% more of Black patients after we overcame the bias and after we solved it, and better performance when capturing more patients from different ethnicity. Also, for the ROC curve, as you can see before, we had more space between the subgroups, which showed we had more bias. Whereas now, after the oversampling, we don't have space anymore between the subgroups, and this means that the model is performing very well for all of the subgroups, and we don't have differentiation between the subgroups, and that's how it should be. Now, to conclude, there are a couple of strategies that we can take in order to design for a fair and trustworthy AI. The first one is to have data awareness. So what I mean by that is to make sure to know what your sources are for data and how they were collected and where, because we don't want to collect, let's say, data from just one hospital in one city, but we want to collect data from different hospitals across the world so that we can get more representative data. And also to try to detect for bias early, so try to check the distribution of the data that you have for race, gender, and age group as well before you start your model. And also we should design for fairness, so apply the oversampling, or there's also other techniques such as undersampling in order to make your data more balanced. And then we need to evaluate and check for the different matrices that we have, such as recall, precision, accuracy, and many more. And finally, we always need to monitor and improve and retest our models in order to make sure that's always fair and we have balanced data. So together, we can design AI systems that are transparent, equitable, and fair. And thank you very much.
Thank you so much, Luna. It's really great work what you are doing. I have a question about the sets of the data that you are collecting. It's because these entities that you work with them have collaboration with the lab of the university that you work for it, or you do a collaboration with hospitals directly in different locations in the world? This is my question, that because when you say that the data sets that you have, it's already biased because this is white people, Black people, I do believe that the source of this data, it's only because they are collaborating with the university. Second, about the strategy of your research and the policy for that research, how it's structured in frame that enable you to collect the data and, let's say, assume that for application purpose. For example, if we talk about some kind of diseases or developing something for vaccinations. Thank you.
Yeah, definitely. So for your question, the way that we have our data, as you mentioned, it's nationally in the USA, so it's not worldwide, and that's why we got more 60%. And the way that we have it is that our research lab is collaborated with different hospitals in USA. So not just one hospital, but we try to do as many hospitals as we can. And sometimes we try to do it worldwide, but because we have some restrictions, it's a bit hard. Yeah.
Machine learning system they use in UAE for doing the checkup for the chest. We are not anymore doing normal checking up. When the person came, we have 20, 30 nationality. They do their residency and visa. They will go through AI checkup, which is for chest, because the systems should be not biased, and the system should be trained for all different type of inclusion data. This is what's because I'm comparing your great work and research here with the system that we have in UAE for checking medical check for the chest area. Thank you.
Thank you.
Thank you so much, Luna. Great work. Thank you.